Now, of course, you're going to be asked to do this, but not yet. Okay? It's not difficult. If you just, if you got the x star here in the position at this point, then you can calculate the distance, inverse square, how much charge is in here, so what's the force or what's the electric field. Okay? Now, we're really talking about magnets here. Okay? And the difference between what you have, if you have point charges, electric point charges, and point magnetic charges, there's quite a bit of difference. The biggest difference is that magnetic so-called charges or magnetic poles occur in opposite pairs. So it's like, instead of this, it's like something like along the length of this magnet, whatever direction you're working in, you have positive poles here and negative poles on the other side of the magnet. Okay? Now, this is not an exact model because what goes on is somewhat more complicated, and we're not actually going to attempt to integrate that because it'd be we could write down the integral, we could use machinery to evaluate it, but we can't use any integration technique. Okay, so we do some approximation, but that's not what's important. What's important is that these are dipoles. Now, you had a problem that I hope you did, that you were supposed to do for homework, where you had electric charge at like 0 A over 2, 0 negative A over 2. And you're getting the electric field at different points along the y-axis and the x-axis. Okay? So if you've done that problem, you'll understand how this works. The field falls off very rapidly. Okay? So in a sense, it's like you have a point up here, or along a line up here. You have an attractive field, a field toward your It'd be nice if this chalk would write evenly, but I think the art of manufacturing usable chalk is kind of somewhere in the past. Okay, you've got this. Okay? You know what? We all drew these things in the wrong direction. I mean, you all drew it in the wrong direction. I said, well, that's not what I was thinking, but okay. And then I accepted it. Okay? Now let me make an observation that what you're supposed to be investigating individually, you're looking at each other, you're talking about it, right? So all the insights that 3 different people could have had have been channeled into the insight of whoever did whatever they did first.
I don't know if we...
Does that make sense?
We actually did talk about that one. Yeah.
Okay? So I thought about separating you, but you can see that far. Okay? So everybody's kind of doing the same thing, orienting things the same way. The aluminum strip is laying on the table. Okay? And just about everything you're doing. Okay? And there are alternatives. And if you're working independently, somebody's more likely to stumble on the most profound alternative, which nobody so far, I think, has, although you're doing some good things. I mean, you're making some good observations, okay? So, part of teamwork is not sitting there, everybody doing whatever somebody else did first, or everybody doing whatever whoever they think understands it best did first, right? You work independently, and then you bring your ideas together, and you amplify the whole process, right? So, I mean, you guys are really good at working at a team. It works really well for you, okay? But sometimes, like right now, it would work better if you would first work independently, right? I mean, in class, you guys discuss things, you bounce ideas back and forth, and you come up with really good stuff. So I'm not really getting on you, I'm just making an observation, and then next time you don't do this, I'll get on you. Not really, okay? So, and one result is that some bozo followed what you guys did, Fortunately, I didn't specify whether this was a positive charge or a negative charge, did I?
I assumed it was negative.
I did too.
Well, I'm treating it as though it was a negative charge, even though I intended a positive, and my first picture was away. You guys drew the picture this way, and I said, oh yeah, that's the way it works. You know, so you understand that even though I know really, really well the direction that that field should have been in, I went and drew it the wrong way. Also because it's natural that you would have done that because you're dealing with a magnet that attracts everything, right? Okay? That's another reason I said, well, yeah, the magnet does attract everything, so we'll do it this way. Okay? So now I'm going to change the conditions. This is not the field, this is the direction of the force, but I asked you for the direction of the force, right? I didn't ask you for the field, so officially I didn't screw up, but mentally I did. So this is a negative charge. Now everything is okay. Okay? But you know, take what I said about having your own thoughts before you get into group thinking. Okay? And by all means, keep thinking together because you're really good at it. Okay? But sometimes you need to think independently and come up with different ideas, especially in a novel situation like this. Okay?